Okay, so what we're looking at here are the results of our two-way ANOVA. We did this. You did this. Um, and these were the results that we found. And that was great. You turned this in, and you hopefully got full credit or almost full credit. There's one thing we didn't do that we need to do for both the one-way and two-way ANOVA, which is a graph. So in your graphs, I want you to have these four things. They have to have these things: a title, axes labels, error bars, which is something that we'll talk about. And I want you to change the colors. So there's a couple of things here. A good graph should be something that you can look at, not look at the numerical results, not look at the written results, and have a really good idea of what was done and what the outcome was. You glance at the graph and you have a really good idea. Is it a significant test? Is it not a significant test? What are the variables that we're looking at? Everything, just from glancing at the graph. That's a good graph. Then also, the reason I want you to change the colors is, I go to a lot of conferences and I read a lot of papers, and one thing that is just like strikes me as these people have put in absolutely the least effort possible is that you'll see people give a presentation. These are like, professors giving a presentation, and you're going through the slides, and then all of a sudden they've got default Excel colors for their graph. Absolute least effort possible. Why should I take these people seriously? Same thing in papers. I mean, that's even worse. The paper, like the default should be like black and white, and you can have color if you want. But then for some reason, all they're doing is putting in the default colors, like the blue and the orange. Oh, man. Definitely strikes me as not a paper I want to read. Like, it instantly just is like, nah, okay, you couldn't even care about your graphs. Why should I pay attention to what you're trying to tell me? So I want you to change the colors. They don't have to be good colors. Like, I'm not a person who's good at graphic design, so like I don't know what is a good color. I just don't want them to be the default colors. That's it. So I want you to change colors. And the other things are things that have to be there for a good graph. You have to title it so people know what they're looking at. Same with axis labels. It's one and the same reason for that. And then error bars, we will talk about why we want to do error bars in a second. So I want you to turn in two graphs. You're going to turn in a graph for a one-way ANOVA, and you're going to turn in a graph for a two-way ANOVA. We're going to use some data from this two-way ANOVA here to make a graph from a one-way ANOVA, but what I want you to turn in is follow the instructions that I'm about to give you for your one-way ANOVA. We're going to make a one-way ANOVA here, but then use those instructions to make a graph for your one-way ANOVA that you turned in a couple weeks ago. So apply what we're teaching, what I'm teaching you now, to that data set. The second thing I want you to turn in is a graph for your two-way ANOVA, which I'm going to walk you through here. So you just have to follow along and understand things and do it and turn that in. So two things you're going to turn in: a graph for your one-way ANOVA, which you'll have to do on your own, but you can follow the lessons I'm teaching you here, and a graph for your two-way ANOVA, which if you follow along with the video, you'll be totally set up for. Okay, so let's go ahead and get started. Just to reorient you, what we did with our two-way ANOVA here is we had men and women drink either water or caffeine. I guess water with caffeine in it. And then they ran a mile. These are the times that we gave them. And there we go. We just wanted to see how fast they would run a mile with caffeine or no caffeine. So this is obviously a two-way ANOVA. Gender, caffeination. We don't want to go through all those yet. We want to cut this down to just 2 variables. So what I'm going to do is I'm going to average across men and women. We're just going to have people who either had water or caffeine. So what I'm going to do first, and you can do this as well, is I'm just going to type in water and then caffeine. And what I'm going to do is equals average, and just average across men and women here. And then we're going to do that trick where we drag it down to, what is that, 21? I went one too far. But that's okay. What I want to do here is I want to do the average. I don't want to do anything, actually. I'm going to delete that one. We only want to go all the way down through water. Next to it, we want to do caffeine. So we're going to take these two right here. We're going to average those, but we're going to put them up here under caffeine. Equals average these two. Then we're going to do the pull down thing. And there's our new data set. Cool. Okay, so when you're making a graph, we talked about this, way back in the beginning of class when we were doing the visualization stuff. But now you actually know how to do ANOVAs. You know what ANOVAs are about. You know what they're testing. So I think we should talk about it again. But what you're using to make the graphs isn't the raw data. If I use the raw data to make a graph, it would look weird. It'd look like this. That doesn't really. I mean, it kind of shows us a range. We could put an average through here, and that would work. So that's fine. We could do a bar graph, and that's like somehow worse. So not great. We don't want to use our raw data. Instead, what we want to do is we want to get an average. So right here, we want to do equals average. And then we can just drag this one over, and it'll give us the average of caffeine. Okay. I forgot to put axis labels here, or just labels in general. So I'm going to right-click, insert, and shift the cells down. You can do the same thing. Highlight both of those cells, right-click, and then click insert and shift cells down. Then what we're going to do is paste those labels in. There we go. So there's the average. That's not the only thing we want, though. But we'll talk about why we want something else first. Let's grab this, water and caffeine. We have the averages here. We're going to go to insert. We're going to go to bar graph. Okay, there's a graph. But that's not good enough, because look at this. I can totally screw with my So people who do data analysis who are not honest people, like, I don't know, jerks and politicians, are going to do things like they'll take this and they'll put this at 0. And then all of a sudden these bars don't look different at all. Or we can put this at 7.8, and we can set the top to 8.3, and now all of a sudden it looks like there's an enormous difference, the biggest difference you could possibly have. Same data, different axis here, and all of a sudden the data look totally different. So how can we get around this? Well, we get around this by delete. Well, we can save that. We don't need to delete that. Let's put it over here. We get around this with error bars. Error bars are going to show you how much error you can expect in each of those columns. So if the bars are big, if they overlap a lot, there's probably not a significant difference there. If they don't overlap, they're very far apart, there probably is a significant difference there. So you can still pull the same tricks. You can make it look like there's a big difference or not, but if you have error bars on it, people are going to know, which is why we always want to put in error bars. There are a couple different ways that you can do your error bars. So like in the game, when you're playing the game of being a publication person, an author of manuscripts, you can do your error bars as a standard deviation. You could do it as a standard error. You could do it as a confidence interval. I'm going to show you how to do 95% confidence interval. It tends to be the one that, it's just what you're expecting. It's also what your test is set at. So if you represent a 95% confidence interval in your graph, then it more closely shows what's actually going on with the statistical test. So that's why we do confidence interval. But people do the others as well. Standard deviations are going to have larger errors. Standard error is going to have smaller error. And confidence intervals usually somewhere in the middle. So the first thing we want to do to compute standard error, right, it's standard error of the mean, which comes from the standard deviation. So the first thing we want to do is compute the standard deviation for water and caffeine. And we'll pull that over so we have it. Cool. Now, the next thing we want to do is to find the standard error. And the way that you do this is you take the standard deviation and divide it by the square root of n. In this case, we have 30 different people. And so that's what we're going to put in as n. So we're going to take this standard deviation, divide it by the square root of 30. There we go. That's our standard error. And we're not quite done, because what we need to do is we need to multiply this by the constant for a 95% confidence interval, which is 1.96. So we're going to say equals this times 1.96, and there we go. This is the error value we need. So now we're going to go back to our graph. Click on the bar. Go over here to the plus sign. Go to error bars, but don't click on error bars. Just go to error bars and then do the little arrow. Click the arrow. Go to more options. You should be in the right place because yours will take you there. But if you're not for some reason, click this where the 3 bars are. And then come down here to custom and specify value. So for your positive error value, go ahead and select the standard error that we just computed. And for your negative error value, also select the standard error that we just computed. And click OK. There we go. Now we have some error bars. You want to adjust your axes so that... Oh, there we go. You want to adjust your axes so that you are showing all of the error bars. This is just barely above 8.4. 8.5 is probably the right place to be in that case. But 7.8, we're cutting off some error bar. So let's try 7. Okay, the whole thing's there for 7. Looks like we could probably go to 7.6. That's pretty good. Now you can see all of the error bars in both places. And look at this. They don't overlap. Cool. So water is significantly slower than caffeine. This is what I'm getting from looking at this. Okay, so those are error bars. That's the hardest thing to do. Next thing you want to do is give it a title. We're going to call this chart. One mile run times by caffeine status. Then we already have an axis label down here for water and caffeine. So we just need to add one axis label. So click on plus, click on axis titles. We can go over here and add which one. We want to add the primary vertical. And we're just going to say (1 mile runtime) and then min in parentheses. There you go. There's your graph. Make it a little bit bigger. There you go. You can copy and paste this now into, we didn't do one really important thing. We didn't change the colors. Come up here to chart design and click on some colors. And you can choose like anything you want to choose, just as long as it's not what it came with. This is fine. You can choose your own colors. You don't have to just do colors that they have. You can do that by right-clicking. You can fill it with a gradient if you want, or a texture. Here, these graphs are wood. I wouldn't recommend doing this in a talk or a presentation. This seems like not a good idea. But you could. There we go. That looks more like something I would have in a presentation. Black background, a little bit of color. That looks great. I'd throw this in. I'd feel great about it. Okay, so there's the graph for one-way ANOVA. Let's keep that over there. Now we're going to do the graph for two-way ANOVAs. It's almost the same thing. But now we want to have more category labels. So let's put it here. We're going to do men, women, water, caffeine. And now what we want to do is we want to find the average up here for men who drank water, which is men and water. Oh, that was easy. Okay, so men and water. Water is this whole big one right here that's really tall for some reason. Oh, it's because of these. So men who drank water, the average is 8.9173. I'm just going to Control C that and Control V it over here. Women who drank water, 7.5. Control C, Control V. Men who drank caffeine, 7.98. Control C, Control V. And women who drank caffeine, 7.7. I don't want to call that number. What? Stop it. That makes no sense. Okay, good. It did paste it. I was worried it was just going to keep thinking it was a phone number. What phone number looks like that? Why does it think it's a phone number? Anyway, it doesn't matter. So we can go ahead and highlight all these cells right here, these 9 cells, and insert and bar graph. Here's the thing about ANOVAs. You can do a bar graph or you can do a line graph. They are both absolutely acceptable. So let's go to change chart type and we can turn it into a line graph. Looks good. Let's do that. So both line graphs and bar graphs are totally fine for ANOVAs. Also for t-tests, also for, all these ones where we're looking for a difference. It's totally okay. Which is better? Well, it kind of depends on you. It depends on the aesthetic. It depends on what you're trying to highlight in the graph. The only thing that's different about that is if you have like 3 or more groups, well, let's say more than 3 groups, more than 3 conditions per variable in a one-way or a two-way, you might want to go with a line graph because you can show changes easier with a line graph. But if you have just a few, like we've got here, we've got 2 in the one that we just did, and we've got 4 in this one. Either one is acceptable. Just kind of like personal preference. All right. So this is what we're going to go with. We're going to do this line graph for now, but we need error bars. So we have variance here, which is not exactly what we want, but it's close, right? So we're going to copy the variances. Oh, that wasn't the variance. Whoops. Oh, we already computed. Oh, great. Okay. We've already computed these. We've already got the standard deviations because I had you put them in the right up here. That's great. So what I copied was the standard deviation. So go ahead and copy that. And if you paste it, it's going to show up like a 0, just like mine did. That's because there's a formula in that cell, and it's trying to do the same thing that the formula is doing. So instead, you can right-click and click on values right here when you go up to paste options. That'll just put in the number. We're going to do the same thing here with women who drank caffeine. Right-click, paste special, or women who drank water, sorry. And then here we're going to take both men and women who drank caffeine, and we're going to copy those. Right-click, paste special, and there we go. There's our standard deviations. We're not done because we have to figure out the standard error for all these. 30 observations per cell, which means it's equals this divided by SQRT 30. Boom. Drag it over, drag it down. But we're still not done. We need the constant for the 95% confidence interval, which is this times 1.96 . What? There we go. All right, now we're ready to do some kung fu. So there you go. There's your error bars. Click on your chart. Click on plus. Go to error bars here. Don't click on this. It's just going to give you like weird error bars that don't mean anything. So go to more options. Which one do you want to add? Do you want to add water or caffeine? Let's do water first. Okay, these are still meaningless. So we need to go over here to format error bars. Click on the 3 little bars and go down to custom and specify the variable. Positive error value is the top one here because that's water. It corresponds to water. We've got water average at the top, caffeine at the bottom. Same for standard deviations. We had water at the top and caffeine at the bottom. So take the top row for positive and negative values. There we go. And now we want to click plus, error bars, more options. Click plus. Oh, because we're selected in those. Click the line that doesn't have error bars. Click plus. Error bars. More options. Go to custom, specify value, and now we want to select the lower two cells for both positive and negative. And click OK. And there's our error bars. We need to change what's going on here. So click on the axis, come over, click on the 3 bars, and then in axis options, we're going to change the minimum to 7 and the maximum to 9.5 isn't bad because we go above 9, so we want to show the error bars. Okay. Good. Then we're good on error bars. We need to throw in a title. One mile run times for, no, 1 mile run times by gender and caffeination. We have labels down here. We've got men and women as this area and this area. We've got water as blue, caffeine as orange. We want to add a title over here, or a label, I should say. So go to axis titles, vertical, and we'll do the same thing that we did last time. 1 mile run time, then minutes in parentheses. Okay, one thing we haven't done, we haven't changed color. So come up here, change the colors to something you like. Oh, there we go. That looks cool. There we go. There we go. That's the graph that we have for a two-way ANOVA. So now you can see what's actually going on. Like, we've looked at the results. We know that there is an interaction. We know that there are some main effects going on. But really what you can see is when you are a man, water makes you a lot slower. Caffeine makes you a lot faster. But if you're a woman, it doesn't really make much of a difference. You're pretty fast no matter what. So having caffeine seems to make men equal out to women. But if they just drink water, they're a lot slower. Of course, this is just made up data. It doesn't necessarily work this way. But this is the kind of thing that you should turn in. You don't have to turn in these, like, you know, sad goth graphs that I like. You could do this one with data points here. You could do, I don't really know how this is different, but whatever. Look like there were some other ones. We changed chart type to column is good. We changed chart type to column. You get like a lot of different things going on here. You could have lines. You could have borders, crosshatches in the back. There's so many things going on. Oh, this is cool. It's got a gradient on it. Hooray. So there's all sorts of stuff. All sorts of crazy fun stuff in terms of layout. Do whatever you want. For layout, it's cool. Just as long as it's not default again. Okay, so your two-way is going to look a lot like this. Should have the same data. You could switch where the variables are. You could do water and caffeine on the top and men and women on the side, so it'll look a little different. But other than that, well, actually, I can show you what it would look like. It'd look like this. This is the one we made. This is what it could look like if you switch men and women and water and caffeine. Now we've got water as the big group, and then men is the green bar. So that's what you're going to turn in. Yours is going to look a lot like this. Just like I said, this one's going to be different because you're using your data that you use to turn in for the one-way ANOVA. Oh, look at this. Man, that's terrible. But you'd get points for that if you turned it in. That's the worst graph I've ever seen. It's not as bad as default, I guess. But wow. I mean, that's like... There's just too much color. Okay. You are good to go. You know what you're doing. Go ahead and do it. Turn it in. Let me just show you really quickly again. Things you're going to need. A title. Axis labels. Error bars. And change the colors. If you get stuck on error bars, come back to this video and watch me do error bars again. I did it for both one-way and two-way ANOVA. You should be okay. All right, good luck.